We know that protons and neutrons go in the nucleus. So that's the first thing we're going to put in our model of the atom. It's the 4 protons, which are positive, and the 5 neutrons, which are neutral. Then we're going to look up here at our chart. You can look at either one of these, okay? So the first thing on the first energy level, you can have up to 2 electrons. We need a total of 4 on our model, so we're going to use all of the available space on the first energy level. We have 2 electrons here on this first energy level. And we're going to look over here, and it can hold up to 4. Or we need 4 for the model of beryllium, so we're not done yet. And we're going to put 2 more electrons on this second energy level. And if you look up here at the chart can hold up to 8. So the 2 of them are going to fit there just fine. And we're done. We have all the parts of the atom here now. We have the 4 protons, we have the 5 neutrons, and 2 plus 2 is our 4 electrons. We know that the 2 valence electrons tells us there's 2 dots in the dot diagram. That's what those 2 dots represent. We also know that this 2 valence electrons tells us that beryllium should be in family 2. We also know that because this model has 2 energy levels, 1, 2, it should be on period 2. Now let's take a look at potassium. The information we learned from the periodic table was it has an atomic number of 19 and 39 and a mass of 39. Now remember, this mass is the total of the protons plus the neutrons. We know that the atomic mass is 39, and that equals the number of protons and neutrons. So something plus 19 equals 39. This is when we need to do our math. We take 39 minus the 19, and that equals 20 neutrons. Now we have all the parts of the atom, so we're ready to make our model. The first thing we know, and the easy part, is that the protons and neutrons go in the nucleus. So we're going to put the 19 protons and the 20 neutral neutrons in the nucleus. Now we look. Our model needs a total of 19 electrons. So we're going to start here on the first energy level, and it can have up to 2 electrons. So we're going to put the 2 electrons on the first energy level. If it's full, we go to the second energy level, and it can have up to 8. So we're going to add this 8 electrons on the second energy level. Our model needs a total of 19, and right now we have 2 plus 8 is 10. So we need more. So we're right here at the second energy level. And we're going to go to the third energy level, which can have 8. Or if we're following this one up here, we have 2 on the first energy level. When that was full, we could have up to 8. When that was full, we can go here and have up to 8 more. So we're going to put them in our model just in the same order. And now our model has 2 plus 8 is 10, plus 8 is 18. We need a total of 19. So we look, when that's full, we go to the 4th energy level, and right now it could hold 2 more. Well, that's plenty of room for our 1 electron. So we're going to add it there. We see that this has 1 valence electron, which tells us there's going to be represented by 1 dot in the dot diagram. When we look, and we see that there are 4 energy levels and 1 valence electron. The 1 valence electron tells us that this element would be in family 1, and these 4 energy levels, 1, 2, 3, 4, tell us that it would be in period 4. Now let's take a look at the periodic table and see if we did this correctly. We thought we would find beryllium on period 2, family 2. Well, if we look along period 2, it's these 8 elements. And that's why there's only 8 electrons on the second energy level. When we look in family 2, for the 2 energy levels, there it is. There's beryllium, right where it's supposed to be. It also has an atomic number of 4 because of these 4 protons, and it shows us here that it has an atomic. So we did this correctly, and periodic table was made correctly, and beryllium is in the right place. Now let's check this potassium. We thought the potassium would be on period 4 and in family 1. So I highlighted family 1 in blue, and we see the K is in family 1. We also had 4 energy levels in our Bohr model, so it should be on period 4. So the first period goes across right here on the top with hydrogen and helium. The second period goes along right here with these 8 elements all the way over to neon. The third period is sodium, magnesium, aluminum, phosphorus, sulfur, chlorine, argon, these 8 elements, and those are those 8 electrons right here. And then we're over here on period 4, and we see where family 1 and period 4 come together. There's potassium right there. It shows it has an atomic number of 19. This one had an atomic number of 19. So we did this correctly. Potassium is in the right place. Now, I'd like you to pause the video for a second and do these next 2 Bohr models on your own. Okay, now you've had a chance to look at these on yourselves, let's review your work and see if you're understanding this. I'm going to put a little Bohr model over here so we can kind of go through how the electrons go just for review. I'm going to cover up the part of the chart that we're not using so it doesn't look as confusing. Okay, remember, 2 electrons can fit on the first energy level. If it's full, it's just like reading a line on a page. You go to the second energy level, and it can hold up to 8. You can think of them kind of like buckets. When this bucket's full, you go to the next bucket. And so we could have 8 more here on the second energy level. When that bucket is full, we can go to the third energy level. And remember I said it's just like reading, like if this was words in a sentence, you read to the end of the line. And when that's full, we can add 8 electrons here on this third energy level. And then it's full, we go to the fourth energy level, and it could have up to 2 electrons. So we could have up to 2 electrons on the fourth energy level. If those 2 electrons are full, you follow this arrow, and it goes back here to this 10, and we see that those are on the third energy level, underneath this 8. So there they are. We're going to put them in the same place, right there on the third energy level underneath the 8. If that's full, we can go over here to the fourth energy level, and 6 more could fit right there. So you follow this chart exactly in order, left to right. When you get to the end of a line, you go back to the beginning of the next one, go out to the end. Now, it asks us to do this nitrogen. So here's the information we would find on the periodic table. Atomic mass of 14, atomic number of 7. Now you guys are experts, and you know the atomic number tells you the number of protons. So the number of protons is 7. We also know that the positives always equal the negatives because the atom is neutral, so we have 7 electrons. To find the neutrons, remember the atomic mass is protons plus neutrons. It's the total of these two. So something plus 7 equals 14. Or the other way we can find it is 14 minus 7 equals whatever this is. So we do our math. 14 minus 7 is 7 neutrons. Now we have all the parts of the atom. The easiest thing to do is put the nucleus in first. So we're going to put in the 7 protons and the 7 neutrons. Now our model calls for 7 electrons. You look up here at the chart. 2 of them can go on the first energy level. When it's full, that's all it can hold. We go to the next energy level. The next energy level can hold up to 8. We only need 5 more. 2 plus 5 is 7. So we're done. We have all the parts to our atom. 7 protons, 7 neutrons, 2 plus 5 is 7 electrons. These 5 electrons on this outside energy level. And I just put, because we're making drawings, I, put extra rings here, but really the outside energy level is this 5. This is our 5 valence electrons, and we know that that is going to be represented by 5 dots in the dot diagram. That also tells us that we should find nitrogen in family 5. So the family is so important. It's represented by the dots, and that's also represented, tells us what family it's in. We see that nitrogen has 1, 2 energy levels. So that tells us it's going to be on period 2. Now let's take a look at this argon. Argon has a mass of 40 and an atomic number of 18. You already know that the atomic number tells us the number of protons. The number of electrons is always the same number as the number of protons because the positives and negatives are equal and the atom is neutral. Now, to find the number of neutrons, this is when we use our formula. 40 minus 18 equals the number of neutrons. So we have the atomic mass, which is 40, minus the atomic number, which is 18, equals the number of neutrons, which is 22. Now we can put what goes in the nucleus on our model. We can put in the 18 protons and the 22 neutrons. Our model is kind of like putting parts of a model together. So we've used these parts and these parts, and now we got to use 18 electrons. So we look at the chart. 2 electrons can go on the first energy level. So we're going to put them on our model. And when that's full, we go to the next energy level, which could hold up to 8. And we're going to check. 2 plus 8 is 10, and we need a total of 18. So we're not done yet. So when this is full, we go to the next energy level, which could have up to 8. So we're going to put them in there. 2 plus 8 is 10, plus 8 is 18. So we're finished. All the parts of the atom are here. We have the nucleus correct, the 18 protons, the 22 neutrons, and then all of the electrons. These 8 electrons on this outside energy level are called the valence electrons. They're so important that they get dots in the dot diagram that represent them. So the dot diagram in this case is going to have 8 dots, and they kind of go in pairs around the symbol. Now these 8 valence electrons and these 8 dots mean that argon should be in family 8, and we see that this model has 1, 2, 3 energy levels. That tells us it should be on period 3. Now let's look at the periodic table and see if we put the models in the right place. So the first one we thought should be on period 2. So I highlighted period 2 with these 8 elements going across from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And I highlighted family 5 because we thought it would be in family 5. And we see where period 2 and family 5 intersect. Right here is nitrogen with its atomic number of 7, and it's in the right place. Now let's check out the argon. We thought argon should be on period 3, so I highlighted period 3 with its 8 possible slots for electrons, and that's why there's only 8 electrons that can fit on the 3rd period. Okay, so we go back to these 2 elements on the 4th period. And we thought argon should be in family 8. So I highlighted family 8 here in blue, and we see where we go across period 3, and in family 8 is argon right there. And we did this correctly.